All right, everybody, welcome back. So today we're going to start getting into the advanced inventory and equipment system. This episode, I just want to get switched over from the tag map that we have now to what's called a FFastArraySerializer. And the FFastArraySerializer I'll get into more as we start making it. But just to get right into it, just to say that this will piggyback off some of the work we've already done. So if you're just tuning in to check this episode out, then my previous episodes where I set up the tag map inventory, there's still going to be some of the stuff in there from it, but not very much. To kind of get right into it, the first thing we're going to do is all of this, including this delegate, is going to go away. We're going to erase this delegate. We're going to erase everything about the inventory map and the locally. Do this on rep cached inventory. So we'll clear all of this out that has to do with the tag map, which means it's going to break everything in here. So get rid of this. Get rid of this. We're going to keep the get lifetime replicated props, but then our... Okay, now we can get rid of add item, and then we can get rid of package inventory, reconstruct and on cached. And then use item, we'll redo that, and then inventory tag map's gone, and then get inventory tag map. That'll be fine, which means then also in our player controller, we have, remember, we need to get rid of begin play. Remember in begin play, we have this owner, where the only thing we're doing is setting that owner locally controlled. So we'll go ahead and just cut out begin play entirely out of that. And then the inventory widget controller is going to have an issue with this. We're going to just clear out all of this. Just do this. Do this, and we're cleared out here, and then we are not going to need the inventory broadcast complete or the scroll box delegate. We'll get rid of these, and we'll get rid of this and this, right? So we'll just have basically resetting. We're basically resetting. Okay. So now that I got all that cleared out, what we're going to do is we're going to come into our build.cs file. And in our build.cs file, hit comma, and then hit enter. So we're going to come on to the next line. So comma, enter, and then we're going to net core. You need to include net core to your public dependency module names. Now that you've done that, we're just going to rebuild. Okay, I have build succeeded. So everything's cleared out and ready to go. So pull up my sleeves for this. Okay, so what we're going to use is a FFastArraySerializer, and we need two structs. We need two structs. So the first one is going to be a U struct, and this is going to be FRPG inventory entry, and this is going to publicly inherit from a FFastArraySerializer item, and we're going to make this a blueprint type. So that way we can make an FGameplay tag, and this will be item tag, and we'll set that equal to default constructed gameplay tag with a U property of blueprint read only, and then we'll make an int32 quantity equals 0. That's all we need to do. We're gonna do inventory first with a FFastArraySerializer because the equipment is also going to be FFastArraySerializer, but that's more involved. We're going to start easy and simple here just to show how this works. We're just going to convert our inventory to what this is. So now that we have a FFastArraySerializer item, which is just a gameplay tag and a quantity, we're going to make another ustruct, and this one is going to be an FRPG inventory list. And we're going to inherit public from a FFastArraySerializer. And we don't need to see this, so we're just going to come here. Now, default is public, so we're going to make a private section. In the private section, we're going to say a few things. The first thing we're going to say is friend class U inventory component. Now, what that's going to do is allow the inventory component the uInventory component is going to have access to our private variables, because the first thing we want is a T array of FRPG inventory entry we'll call entries. This is U property. And so now our inventory component will have access to these entries, but nobody else will, or direct access. And the second thing we're going to make is a T object pointer, and this is going to be to a U actor component, and it's just going to be called owner component. And we're going to make a U property, but we're going to say not replicated. That's going to be not replicated. So in the public section, I need two constructors, one for the owner component and one without. So I need an FRPG inventory list constructor default owner component to null pointer like that, and then I need an FRPG inventory list with a uActor component pointer called inComponent like this, and then owner component to inComponent like this. So now I have two constructors, one where is just default, and then the other one where I include a component to fill in to register the pointer for the owner component. Now a FastArraySerializer, this is FastArraySerializer contract. Okay, you get 3 functions with 3 timings. 2 of them are very useful. One of them I don't know because I can't ever seem to get it to work. But anyway, let's do this. They're all void. So void, the first one is PreReplication Remove, and it takes a const t array view of int32 called removed indices, and then it takes a int32 called final size. And then void, we have post replicated add with a const t array view of int32 called added indices, and an int32 of final size. And then the third one is void post replicated changed. Post replicated changed or changed? Let's find out. Let's right click on this and we'll go to the declaration or usages FastArraySerializer. It is PreReplicated remove, post replicated add, and post replicated change. Let's just change const t array view int32 changed indices and int32 final size. Okay, so we have that. The next thing we're going to want to do is set up for the NetSerialization, which we already know how to do NetSerialization setup, right? Template, struct, t struct op type traits for an FRPG inventory list, colon t struct ops types trait base 2 for an FRPG inventory list, which is just going to have an enum that is going to say with net delta serializer equals true, with net delta serializer. So, and then this one isn't a virtual override. This is just we don't have to virtual override it. We just say bool net delta serialize. And then it's going to take a non-const reference to an fnet delta serialize info non-const reference called delta parms. And then we'll just define it right here, because all you have to do is return fast array delta serialize. Now this is a template function, so add a template requires 2 things. The first thing that it requires is what is the entry, so that's an FRPG inventory entry. And then the second one is what is the FastArraySerializer, that's the FRPG inventory list. The first of these 3 parameters is what we're actually changing, which are the entries. The second one is the parameters that we're changing, so the delta parms. The third one is, again, it needs a reference to a FastArraySerializer, which in this case is just to dereference this because we're inside a FastArraySerializer right here, right? So now we have net delta serialize, and we don't have to do anything else for net delta serialize. Like we don't have to define anything further for net serialize at all. All we have to do is add the functionality to this. So the first thing I'm going to do is come in here and I'm going to say add item. Oh, this would be a void add item, and it'll say const f gameplay tag item tag and num or int32 num items equals 1, and then void remove item const f gameplay tag item tag int32 num items equals 1. And then we're going to set ourselves up for a little server verification. So we'll say bool has enough, and then that will still take a const f gameplay tag called item tag and then 32 called num items. Set that equal to 1. So holy cow, we got a whole bunch of stuff here, right? So let's make definitions for all 6 of these. Oh, okay. So before we do that, we're going to come back here. Now that we have all this set up, we're going to come into the public section under here, and we're going to make an FRPG inventory list that we'll just call inventory list. And then we're going to mark this as a U property, just replicated, not replicated using. We don't need a rep notify. We don't need none of that, right? It's just all built in special. So this inventory list, though, during a constructor, kind of like how we're doing here on this constructor here, on this constructor where we say, hey, if you do this, you pass in a component. On the class itself, the class constructor itself, you can do the same thing with its member variables, right? So if I come down here, we can do the exact same thing. I put a colon and then come to the next line, and then I can say inventory list, and I can initialize it with the component of this, which is the inventory component, right? So just like we're doing for the owner component, where I take this constructor and then I just do this right here. I'm just creating it here and I'm initializing it with this. So now I have an owner component inside here. So what are we going to do when we add items? Well, we're going to have the concept of stacking, right? So the first thing we're going to want to do is loop through and see if we have it, then we're going to add to it. If we don't, then we'll make a new one and add it to it. So we're going to say for, and we're going to do auto, and we're going to call this entry it for entry iterator, and we're going to set that equal to entries dot create iterator. And then you can just, the condition is just entry it, and then you can say plus plus entry it. That's all you have to do, because then we could take an FRPG inventory by non-const reference, we'll call entry, and we'll just set that equal to a dereferenced entry it. Now that we have that, we can say if entry dot item tag dot matches tag exact item tag, then what we can say is entry dot quantity plus equals num items. And then here's the magic. Here's the magic. Net delta serialize. See, regular net serialize, what we had before, right? The map breaks down into structs and then it replicates the whole array every single time that map was changed. You have to send across the network the entire array, both arrays of all the information every time it's changed. So if you have 75 items and you add one, you have 76 to replicate, and then you use one and it's another 75 to replicate. The magic of delta serialization is that it is smart enough to understand which item has changed and which item needs replicated. We mark these items, which one needs replicated, and then it will only replicate and change the data in that single item or that set of items, depending on how many got changed, right, in this update call. So it's even like the most network efficient because you have an array of 125 items in your inventory. You use one. Well, the only thing that's going to be sent across the network is the one that got used. It's not going to send the whole thing. That's the magic. How do we do that? We mark things dirty. So we mark item dirty, entry, and then we just simply return. This is going to say, hey system, hey game, this entry is now dirty and needs to be updated. And then in the next update call, it will grab that entry and update it. And then here's the thing though, what if we don't have it that we're just adding to it? Then we need to make a new one, right? So we're going to say FRPG inventory entry, and we're going to make it a reference, and we're going to call it new entry, and we're going to set that equal to the entries. You can just call add defaulted get ref, and that will add a new defaulted entry in there, which is just going to have the default is just a constructed gameplay tag and 0. That's all it's going to be in there. So because we have it by reference though, we can say new entry dot item tag equals item tag, and then new entry dot quantity equals num items. And then we have to mark that item dirty, mark item dirty, new entry. So there we go. So now if we got that, then it'll add the item in there, it'll mark it dirty, and it'll set it for replication. And then remove item. We're gonna do kind of the same thing. We're gonna say for auto entry it equals entries dot create iterator entry it plus entry it FRPG inventory entry reference entry equals dereferenced entry it. And if entry dot item tag matches tag exact item tag, then we're simply going to say entry dot quantity minus equals num items, and then we'll mark item dirty entry. Now what is that? All that's going to do is simply do that. Now has enough. What are we going to say? We're going to do this again, right? For auto entry it equals entries dot create iterator entry it plus entry it. We're gonna check if, FRPG inventory entry reference entry equals the referenced entry it's if entry dot item tag dot matches tag exact item tag, if entry dot quantity is greater than or equals num items, return true. If it can scope through that whole list without finding it, we return false. So that's just basically going to check all of our items and say if we call this function and we give it an item tag and a number of items, it just returns, do you have this item and enough of these based off of that? It just has enough. That's all we have to do. And we'll get into these here in just a second, because what we're going to do is come down to the rest of our functions. We have server use item, and add item and everything. So here we go, we're on the server. We're going to add item, server add item, and then all we have to do here is call the inventory list, and we can call add item with the item tag and the num items. And that's all we have to do right here. And then use item comes through, and then we have server use item. So let's do our verification, right? So server use item is going to be called by a client, right? So they don't have authority, and a client is going to send the data, use this item tag with this number of items, right? So now we're here in the server RBC, so now we're on the server. So if the client sends a request, we can take the server first and take the inventory list and ask, has enough of the item tag and the num items? And then we can say use item with the item tag num items. So the client can send over to the server to use however many of whatever items that they want, but only if the player's server version of their inventory list is kept up. Only if the server's version of it has enough of those items will actually continue to use the item. So here's the thing though, we can't just, if you're using clients or if you're using servers as players as well, we can't just go ahead and say and trust the server 100% of the time either. So even though we're on the server here, we're also going to say if inventory list has enough of the item tag and num items. And we can actually move all of this to here. Whoa, why is my... So we can do that. And then we don't have to call add item right here because we're on the server. We can just call inventory list dot remove item, and we can say item tag, and it's removing one. So because you defaulted to 1, you can just say item tag, and then you can leave that there, and the default 1 will be assumed in this situation. So you don't have to put item tag 1 because we defaulted to 1. You just put item tag. Okay, so now we're going to come back up to the replication. Oh, super, get lifetime. We need to do rep lifetime. Excuse me. Do rep lifetime here to the U inventory component. We need to replicate the inventory list, so we still need that. And I think that included something I don't need, did it? No, it didn't. Okay, so PreReplicated Remove is called right before something is removed from this array. However, I find it very finicky and unreliable. Out of the 6 of these fast array serializers that I've made and implemented in different situations, I've never had one time where my fast array serializer in the PreReplicated Remove was able to consistently, reliably give me the data on time if the server is maintaining control of this array. So as of now, if you can figure out what to do with this, go for it. I don't know what it is reliably good for. Okay, but the two that are really good are the post-replicated add and the post-replicated change, right? So in the post-replicated add, well, here's the thing. What can we even do here? We can come back here, and if we go underneath the inventory entry, but above the inventory list, and we come right in between, what we can do is declare a multicast delegate one param, and this is going to be f dirty inventory item signature, and it's going to just do a const frpg inventory f by const reference, and we're going to call this dirty item. So because we declare it underneath here, we have the data needed to fill in the parameter, but then we declare it above here, so we can come here and say f dirty inventory, and this is dirty item delegate, and we just leave it right here. So this is in the public section. So now that we have that, what we can say is for const int32 index through the added indices, we can say frpg inventory f reference entry equals entries at index. Oh, excuse me, we don't have to do that. We just say dirty item delegate dot broadcast entry, because this is only going to do it on the ones that were added. And you can do essentially the same thing, but instead of indices, we could do changed indices. So now that we have this dirty item delegate, though, this is only going to happen on client. So let's take care of the server. So what we're going to say is if add item, here we go, mark item dirty, entry quantity plus that, and do that. Well, before we return, we're going to say, remember we have the owner component, and we initialize it with this component, right? So this owner component is still the inventory. We can say get owner, which is going to be the player controller, right? And then we can still ask it if it has authority. So if it has authority, then we can take that and broadcast the entry. And then we need to come down here. If it gets to here, we need to broadcast the new entry. Okay, now that we're broadcasting it on add item, then we need to also broadcast it on remove item. So we'll just paste it here. If owner component has authority, get there. And then we have it broadcasting for the clients there. So we have it there on the server and on the clients taken care of. The next thing that I want to do is we're going to make a function down here, and this is going to be a T array of frpg inventory entry return get inventory entries. And we don't need to make this blueprint callable or anything. And we'll just return inventory list.entries. See, so the inventory component has access to the entries as a private variable because it's a friend class. But everybody else that's going to have access to the inventory component, they're going to be able to access the inventory list, but not the entries directly. So we're going to make this public getter that will just retrieve specifically the entries for us. We're going to want that. Okay, so the next thing we're going to need to take care of is our widget controller, right? We're going to need to take our widget controller. So back in our inventory widget controller, we can get rid of this for declaration for the struct for that packaged inventory. That's out the window. And then now we can come into the bind callbacks to dependencies and everything, and we can say owning inventory, we have access to the inventory list, which inside of it has the dirty item delegate that we can add a lambda to, capturing this, and it will give us a const FRPG inventory by reference called dirty item. And then we need to say f master item definition item equals owning inventory item get item definition by tag, passing through the dirty item.item tag. I'll take the item.item quantity equals dirty item.quantity, and then we can take the inventory item delegate and broadcast the item. And then we can do kind of the same thing, but we have for const f rpg inventory by reference entry, and we're going to loop through the owning inventory. I have access to the get inventory entries now. And then for all of that as well, we're just essentially going to do the same thing here. But instead of dirty item, it's just going to be entry. It's just going to be like this. So with that, let's go back into the editor. Okay, now that we're back in the editor, we're going to come into the blueprints, inventory, widgets. Let's see the inventory itself. Okay, what's going on now? Okay, so we don't have the scroll box and the broadcast complete anymore, so we can get rid of handle scroll box reset. We could do this. We need to still have the active item widgets bind their button, but we're going to do active item widgets different. Those are no longer valid, so we're cleaning this up and simplifying this quite a bit, aren't we? Okay, so we can just hold off to that for a second, and then handle inventory, handle this, get the quantity, and do this. Now, however, remember this is going to fire. Previously we had it every single time an item changed, it would rehash, it would clear it and send every single item. But now this delegate is only broadcasting on specific item changes when an individual item changes, right? So we don't want just to generic lump these together anymore as just an array. So what we're going to want to do is change the variable type to a gameplay tag to start, and then we'll change this to a map. So now your gameplay tag is your key, and the value, the key value pair, right? So the pair value is going to be a W item row object reference. And we can save that. And then we can take this, and now that we've done this, we can add, and it requires us to add a gameplay tag and this widget. Well, we have the item row widget ref right here, so we could just add that there. And then I want to take the item with the item definition, and we'll just put the item tag here as well. So now that we have the item tag, this is going to label specifically this item tag to this widget. But what that means is before we create a widget, we're going to want to take these active item widgets. We're going to need to break this, because I need to, off this, call find, right? This is what we do in C++ as well, right? In the character class default information in our other maps, you call find on it, right? And this is a pointer. They give you a Boolean here because this is a pointer, and if this is not valid, bad things can happen if you try to use it. So we'll try to find an associated widget associated with that item tag, and if it's true, then all we're going to do is say update. Oh, what is it called? It's called set quantity text. Just going to set quantity text, and actually we can open this down and say the item quantity. And that's all we want to do. Because if it's already there, we just need to change quantity text. If not, then we'll create a row. Oh, and then I need to make sure I get item, because we need to hook the item up into here, so when we use it, it can apply the gameplay effect to ourselves. So that will do that. So if I come back in here though, now I'm going to loop on this array and we're going to do this, but we're going to do this differently. We're going to start with a custom event. And this is going to be bind item button clicked. And it's going to take a gameplay tag. And this is the item tag. And actually I can get rid of this because all I'm going to do is take the active item widgets and we're going to call find again based off the item tag. Then if it's true, then I'll use this pointer to bind right here. Then I come back into here, and then once I'm done here, I can call bind item button clicked, and it wants the item tag. We'll just send it the item tag there. So now also we're not, when we were doing clearing the scroll box and handling all the scroll box and everything, that was a lot of loops, right? So now by also changing this, we're getting rid of a lot of bandwidth saving on if you have a large array of items, we're saving on the bandwidth by not sending over so many items, and we're saving on our CPU cycles here by getting rid of a lot of these loops, right? If one exists, just set the quantity text as opposed to one changed. So unbind every single item and do all of that on loop. So it's quite a significant change here. But other than that, everything else should stay the same. And we'll just move this up here. So this is our entire widget now. It's pretty simple and straightforward. So let's take a look here. Oh, excuse me. We need to come to the player controller. Because remember, we're doing the abilities on number 1. We took away the inventory. So number 1 is that, and number 2 is use that. And oh, we have health and mana potion. So here's the thing. Ability system test, add mana. We can say test add shields. And this will just do shield instead. It'll just do shield instead because we have shield with a little bit of damage here. We can see this. So I press tab and then I press 1. Okay, so health potion 1, mana potion 1, 2, 2, 2, 2. And then I can click use on health potion. Server used health potion, nothing happened, but the mana potion and my shield is going up. So the inventory functions exactly the same. At the end of the day, the inventory is functioning the exact same way, except we've just done it a lot more optimized for sure. Now there is just one final issue to address, and I don't know if you guys caught it or not, but if I have items and I use them, I go down to 0 and I can't use them, right? Because the inventory list has enough is not letting me use any because I don't have any. But it's sitting here at 0 and it doesn't go away, right? It doesn't go away. And we need to handle that situation. So if I open these, come back to inventory, when we handle inventory item received and make an item row widget, what we can do is take this where it sets the quantity text. We can back this up a little bit and we can take this and we can say greater than 0. Not greater than 0. We only really want one case, so we can say equals 0. And if that's the case, then at that point we can call unbind event from action button clicked, remove from parent, and then take the active item widgets and remove get item break. So I'm going to do this, and we're going to come up here like this. Try to make this more readable, legible. Okay, so if it finds one, it'll check if the quantity is 0. If it's not 0, it'll just update the quantity text. If the quantity is 0, then it will unbind, remove the widget, and then remove it from the list. So that won't impact us re-adding it, however. The only thing it will impact is it's gone, and then it's gone, and then I can add more. But it handles the situation to get us rid of the zeros.